So with those kinds of numbers, most people in this field believe that there must be life out there because there is so much potential. And this is where I come back to my definition of astrobiology, studying the potential of the universe to harbor life. We believe that potential is very, very high, but we still have not discovered life anywhere other than on Earth. And science is not about belief, science is about evidence. So we believe this, it motivates us as scientists to pursue this field, and we are accumulating the evidence, and I think many scientists believe that we will in fact discover life beyond Earth. So, just to summarize this part of the talk, astrobiology is the quest to understand the potential of the universe to harbor life beyond Earth. In pursuit of that understanding, astrobiologists study the origin and evolution of life on Earth. We only have one example of life to study. All life on Earth shares a common origin. We all have the same biochemistry. Every organism, from a microbe to a tree to a human being, all shares the same basic biochemistry and the same genetic machinery. So we only have one example of life to study, so we study that example very carefully. We particularly study how life on Earth has adapted to these extreme environments that we did not think were habitable, particularly because some of those extreme environments may have similar environments on other planets. And so understanding how life adapted to those extreme environments on this planet will help us understand how life might have developed and adapted to environments on other worlds. Of course, we study ways to detect life, both in situ for missions that we can actually send to another planet, like missions to Mars, and I'll talk about one of those in a little while. And we also study how to detect life remotely, because we cannot travel to a planet around another star. So the tools that we have to study planets around other stars are intrinsically astronomical. We can look at the radiation coming from that star and coming from that planet. So that requires the ability to understand the characteristics of a planet by remote observations, and also to be able to detect life by those remote observations. We study the potentially habitable environments on worlds around this star and others, and as I've mentioned, the formation and processing of biologically important compounds like amino acids, etc., in space. Now, many people will think that astrobiology is the search for life elsewhere, and it is. It's an important part of astrobiology. But in order to search for life elsewhere, you first have to understand where and how to search. And so much of our effort is